let's see if I understand the problem. You have a bunch of sorted numbers. Your target is 9. Um, 0, 1, 2, 3, 4. Yeah, straightforward. Like you have to pretty much output the index, right?
Mm-hmm.
9 exists in nums and its index is 4. Okay, makes sense. So 2 does not exist, so it returns -1. Okay. Hmm. Cool. Yeah, I think it's pretty much the same implementation. But let's see how I deal with this. So the first thing we have to do here. By the way, I should check the constraints and stuff. Like,
Mm-hmm.
okay, it seems to be like the same.
Yeah, very similar.
All entries unique. Yeah, pretty similar. Okay, so let's get our hands dirty here. um, First of all, we should let's do the pseudocode, right?
Yeah, sure.
Um, we should define our left and right pointers. Uh, After that, we should iterate using a while loop.
Mm-hmm.
Um, the what is it called? It's called the escape clause.
The
The
condition?
condition. Yeah. The condition for it to exit. Escape condition, escape clause. Like there's a specific term for it.
I just call it the condition since it's
Okay.
a conditional.
Okay. Yeah. The condition should be that left is equal or greater than right pointer. I don't know if that's concise. That's not too concise, but okay. So the side here, we should define where our middle is.
Mm-hmm.
Um, at every iteration, it gets redefined,
Yep.
like recalculated. Yeah, because we could like ideally we could just do like define. We could sorry. We could ideally. I don't know if that's efficient or not in terms of like the call stack, but we could like define uh, middle uh, or mid variable side and then just change it, right?
Yeah, you
Every
could.
iteration, it just gets recalculated instead of uh, declare declare. So yeah, instead of just recreating the call stack, just calculate it. Um, so the first thing we have to do is like check if uh the 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 nums mid. I don't know. I would like to write that without having to put code. Like how would I write that? If the element,
Yeah.
uh,
If the current element.
yeah, yeah, if the current element matches the target, if so, return index. Okay, so still here inside the while loop. Check if the current element is greater than target. If so, if the current element is greater than target, that means that let's say this one here 9, let's say 12, right? So 12, not it's not gonna get there, but let's think. Basically, this is where it starts from the left, and this starts from the right.
Yep.
So you have to uh, how do I say that? Check if the requirement is greater than target. If so, um, I'm looking for the. I know what I'm talking about, but I'm looking for the right terminology. If so, recalculate. Um, right. Um, Okay, I guess so.
Yep.
If the terminology is wrong, I apologize.
No, that's cool. Makes
The
sense.
same thing is smaller than target. If so, we calculate left because that means it's it's to the left of the target. Here it's to this is to the right of the target, and this is to the left of the target. So you want to close in, right?
Yep.
And this is we escape the while loop. Since we weren't able to find a match and the condition was already met, we need to return something. So return -1, which I believe
Exactly. Yep.
is the probably yeah, it does not exist. Okay, so that is like pretty much they'll. I'm not sure if I'm wrong here. Correct me if I'm wrong, but they're all kind of same to be the same. It just changes like what you return. Like you could return the element. You could return, where it should be in the array. You could return the index. You could return something else, whatever. But
Yep.
it's kind of like a cake recipe. Like it's always kind of the same.
Yeah. Yeah. Yep.
So yeah, it's okay. Let's see if I still remember. Um,
There are definitely some harder binary search problems. We could definitely
yeah,
we could visit some of those like down the road if you want to, because these are more simple, just so you can really grasp the concept. Once you grasp the
yeah.
concept, we can move on to more advanced
So
ones
it
for sure.
does get harder. Okay,
Yeah, yeah, yeah.
okay.
Because sometimes you sometimes this binary search is just a piece of like a 5 piece algorithm, you know.
Oh, okay.
So when
It's
you're
like
when you're combining a binary search, this is a small piece of like multiple other like another 50 lines of code, and if you have to put it in the beginning, you know, like it gets more
mhm.
complicated. But yeah, this is good to start off.
Okay, absolutely. I think if I get asked something in an interview, it's probably going to be this something like this. Uh, anyway, so since we're gonna be changing the values, we should do like left is 0, of course, because that's the 0 index.
Mm-hmm.
And we should do right, which is gonna be nums dot length -1. The reason is like if we have like how many have we? One, two, three, four, five, six. So we have like 6 elements. You want the index, so you want 0, 1, 2, 3, 4, 5. So you want this to be 5, not 6.
Yep.
Uh, so now you gotta declare the middle variable, but it has to be inside, right?
It could
Okay,
be
yeah,
outside or
yeah,
inside. Yeah.
yeah. I'm just gonna declare like I don't even have to give it a value. Like just like to let admit I don't know. I don't know if it's useful or not. I could, or do you think it should be 0 or nothing at all? Like define like doesn't matter.
Since you're actually going to be giving it a value down here, you don't have to give it a value here. But if you were like incrementing here, then you would have to give it a value. Because if you tried to increment an undefined value, you would get
Yeah,
not
yeah.
not a number. But as long as you're actually assigning a number to it in this line of code, you should be good to go. You could just declare it here and then initialize it later.
Yeah, I mean, it shouldn't hurt to do this, right?
It's more clear. It's more
Yeah, I
clear.
think so. Yeah, makes sense. Okay, so iterate using a while loop. So while, uh, and I don't remember if you have. I think you have one or two. I don't remember. I think just one. While. So, uh, we have to. This is the hardest part for me is finding where the middle is because it gotta it kind of you know it was a little bit like tricky. Uh, but if I remember correctly, since left is 0, we should start with left. Um, and you want to add, uh, and this is here. Right is like the biggest index number, right? So and you should uh, do right, which this is gonna be like how many are we on? 0, 1, 2, 3, 4, 5. So this is gonna be, I think the value is gonna be 5. So it's gonna be 5 minus, oh, it's, wait, yeah, 5 minus 0 plus 0. Okay. Um, this could be fractional, so we need to do something like math floor.
Mm-hmm.
Um, and if I remember correctly, we divided by 2.
Yep.
Okay.
So let me go ahead and just say something really quickly. This right here, this method, the only reason you're doing math.floor right
Yeah.
minus left right here divided by 2, and then you're adding left to it is because in languages like Java or C++, sometimes if right and left are too high, like the size of the array is um, higher than the integers that are allowed in those languages, and then you do right plus left, you'll get an error in those languages. And so the way to overcome that issue is to, instead of doing right plus left, you do right minus left, and then you add left. But another method, in a way that you could do it in JavaScript that you're probably not going to face any issues and it's simpler,
Okay.
is just do right plus left. So right plus left divided by 2. And since we're not going to worry about like going over the size of integer allowed like you are in Java or C++, in JavaScript you could use this one perfectly. It's simple and it's the same thing. So right
Yeah, it's way
right
simpler.
is
Yeah.
5, left is 0, the total is 5 divided by 2, 2.5, rounds down to 2, so it's going to bring you to the same exact spot that this one's going to bring you to. This one just accounts for some problems that you'll encounter with
Okay.
Java or C++, but this one's simpler.
So yeah, it's way simpler. I'll be honest. uh, okay. So let's substitute that. Um, can I erase that?
Erase them, comment them out, whatever you want to do.
Okay. Let's put it like the old stuff here. So we have a reference, right? Okay. So where middle is, so math floor basically means that if, let's say this is like 5, yeah, this is 5, and this is 0, it's gonna be 2.5. Sorry, it's gonna be 5 divided by 2, 2.5, and then it's gonna be 2 because you don't want it to be fractional, right?
Yep.
So okay, so we have it right here. So now it's time to check if the current element matches the target. Uh, if so, return. If I remember correctly, you return the index. Yes.
Mm-hmm.
Okay. So if uh current element, which is num mid equals target, you return mid. You don't
Yep.
want the element, you want to return the index.
Exactly.
If num's mid is bigger than target, uh, yeah, let me put it put pseudocode here. That helps a lot, by the way. Pseudocode is like little life changing stuff. If check if the current element is greater than target. If so, recalculate right. So how do we don't return it, by the way. We just redeclare re, not redeclare, like redefine, right?
Yep.
And that would be the mid value minus 1,
Yep.
because you want to go from the right to the left,
Exactly.
the position. Um, I could use an else here, but I think it's cleaner just to do how the way you did it. I think it's easier to understand. But that's
Yeah, I
my
agree.
opinion. Like,
Nah, I agree.
uh, and here is the same. Like you're like closing in, right? So if you're here, you want to go here, and if you're here, you want to go here. And of course, when the while loop loops again, uh, it knows, like in mid is gonna be redeclared, and let's say, yeah, let's try. Let me try to. We know it's pretty much done, right? So we should return -1. Uh, check. Yeah, just a moment.
You're
I
quick.
think
You
this is
could
kind
tell you have the keyboard shortcuts down pat. That's nice. That's convenient. It makes it way better, right?
yeah, it does. So okay, so basically, let's see if we can. like do this in comments or stuff like you did. Let's take this. Uh, I think you did in your. Let's do two, because it's probably gonna take. Uh, I don't know if it's gonna take longer or not, but um, target two. So left equals 0 and right equals 5, because there are 6 elements, right?
Mm-hmm.
And mid, we start at 0. Okay. So when it's when the first time it gets here, it's gonna calculate right, which is 5 plus 0, 2.5. It's floor, so it's gonna be 2. So mid is gonna be 2. We just checked it. Uh, what is nums 2?
Here, you could even
Nums 2.
do this to make it a little more clear too.
Yeah, absolutely.
Just move R there, and then move mid to the, I guess, first letter over the position.
First letter over the position.
Yep.
What do you mean by that?
So L is over the -1, the M is over the 2 position, the R is over the 5
Oh,
position.
okay. Makes sense. Yeah, that's way more visual. Okay, so we check what mid nums 2 is, right? So nums 2 is like 0, 1, 2 is 3. So is 3 equals to the target, which is 2? No, it's not. Then we ignore it. Uh, so obviously 3 is bigger than 2. So this is the thing that's going to happen here.
Mm-hmm.
So right is gonna be redefined. So we have right here. Right is gonna be defined by mid, which is 3, minus 1, which is gonna be 2. Um, am I correct?
2 minus 1, right?
What did I say?
You said 3 minus 1 because you were looking at the value of the element, but the,
Oh
yeah,
yeah.
yeah,
Oh, okay. Yeah, you're right. I'm looking at the value. I should be looking at the index. Sorry.
that's good.
So
That's good.
yeah. So 5 equals sorry. Okay.
Nah, you're
Right.
good. Yo, when you make mistakes, when I make mistakes, when you make mistakes, I get happy. I get excited, man. I like that because when you make mistakes, that's the territory you're actually learning in. That's where the learning occurs. If you did this all flawlessly, you're not learning. You're just reciting
Yeah.
something you already know. So the fact that you're making small little mistakes, like this is the perfect environment where you're actually learning. So this is good.
Yeah.
Yeah,
I
yeah,
I agree with that.
yeah.
So let's try to read the code. Let's say here what it said. So we know that 3, which is this, is bigger than 2, which is a target.
Mm-hmm.
So what we're gonna do is like we're gonna redefine this, or um, what is the value of mid? Mid is 2, so 2 minus 1 is 1. So right is going to be 1.
Mm-hmm.
Is that correct?
Yep.
Okay. So this is really okay. So right here,
Yep.
yes. Awesome. So we do the iteration again because it skips everything. There you go. Is left uh lesser than right, or equal than right? No, it's not. Left is 0 and right is 1. So just keep going.
Yep.
Mid gets recalculated. Right is 1. Left is 0. So 1 divided by 2 is going to be 0.5. But since this is math floor, mid's going to be 0. And then we check if nums mid is equal to target. Nums mid would be minus 1, which is not the same as 2. So we skip that. We check if, uh, okay, let's see here. So the target is 2.
You can move mid right here.
And
So.
minus 1, yeah, and minus 1 is certainly not bigger than the target. So it actually is smaller than the target. So now we have to redefine left. So left is going to be mid, which right now is 0 plus 1. So left's going to be 1. And then we move it here.
Yep.
So we do the while loop again, and then we check, is left uh, less or equal than right? Yes, it is. It actually is. Uh, then what happens is that we uh, wait. Um, yeah, it's correct because there's no element two here, right?
Yep. Left is equal
So
to right, so you continue to run the for loop or the while loop one more time.
oh wait, wait? Okay, I'm a bit confused because the condition here is left is smaller or equal than right, and right now they are.
Yeah, they're equal to each other. So you keep doing it.
Okay because you're
Yeah, because left
yeah
is
this
less than or
confused
equal
yeah
to right. It evaluates to true, and as long as this,
yeah
no matter how long this is, as long as it evaluates to true, then you run the
mm-hmm.
code inside. Yep.
I was confused by this for some reason. Yeah, but what you mean is like left if left couldn't you do this like
No, because then you would have broken out of the loop on the last iteration, and you would have never found because two could be in this position, two could be in the one position, and if you did that,
mm,
then you would never get left or you would never get mid to the one position. It would have skipped directly from the two position to the zero position, and then when you incremented left on line 22, it would have checked is left less than right, and it's not less than right, it's actually equal to right. It was less than right in the zero position, but now left and right are both one. It's not less than right anymore, so you would break out and return -1,
yeah
which is right for this
okay
problem. But if you did that test with
yeah
the first problem, or if the value 2 was where the value 0 is, then you would actually
mm-hmm.
get the problem wrong. So less than or
Yeah
equal to
absolutely
is correct. Yep.
so yeah they're equal so we just keep going so we're gonna recalculate mid again right is 1 left is 1 that's 2 divided by 2 is 2 sorry is 1
Mm-hmm.
2 divided by 2 is 1 so this gets redefined as 1 uh check nums mid 1 what is nums mid 1 that's 0 is that equals to 2 no it's not um then it checks for this uh nums mid 1 is 0 which is not bigger than the target then it checks for this which is correct 0 is lesser than 2 so we redefine this so left is going to be mid is 1 so 1 plus 1 is going to be 2 and then we go back here and check the condition is left less or equal than right no it's not because left overtook right it's bigger than right
Mm-hmm. It passed
so
it.
yeah it passed it so we escape the while loop and we return -1
Perfect.
right
Let's test
okay
it out.
okay
Let's see. All right, so we are node
yeah
1.js, console.log, search for to some. Oh, I'm in the wrong file.
it's just to run code
There we go.
do you
For
know about
for
it
-1, right?